Good afternoon. At the outset, I would like to congratulate all the listeners, all the budding scientists, and the scientists present here. A very happy National Science Day. And today I will be talking about a brief bio sketch of Sir C V Raman, and will be discussing in short his achievements. And Sir C V Raman was an Indian physicist, and his discovery created evolution in the physics. And as far as for science in India is concerned, this discovery was done at a point where India was not having any scientific budget. The resources were quite less, and one has to manage things. So before coming to the scientific achievements and the biographical sketch, let's have a look at the recognition that Raman got. His achievements started from the FRS medal in 1924, the Knight Bachelor in 1929, the Nobel Prize in 1930, the Franklin Medal in 1941, and the Bharat Ratna, which is the highest civilian award with the Government of India in 1954, and the Lenin Prize in 1957. Apart from these notable and well recognized facilitations, he was also awarded with other medals also, and the American Chemical Society also recognized his work. And government of India from 19 has decided to celebrate the 20th February every year as a National Science Day. And the importance of this day, this specific 20th February, is in regard to the discovery by him. He observed the Raman scattering process on this day. So this National Science Day is in the memory of the discovery made by Sir C V Raman. Let's start with the initial bio sketch. He was born on 8th November 1888 in the village near Trishulapalli in South India. This is the southern India. This is a small village, Trishulapalli. And his father was Chandrasekhar Iyer and mother was Parvati Ammal. These are the photographs of the father and mother, and this is the house where he spent his childhood. His father was a science teacher, and when Raman was about 3 years old, the family moved to Vishakhapatnam, where his father got a job of a lecturer in mathematics and physics. And Raman matriculated at the age of 11 years, FA at the age of 13, and the BA at the age of 15 years from Presidency College, Chennai, and MA at the age of 18 years. And he was fond of reading, and he used to read a lot. And during this the reading process, he was influenced by the German scientist Helmholtz, and he published his very first paper in the philosophical magazine, which was published by from London at the age of 16. And this paper concerned with the diffraction of light from the prism, and another problem which he tackled was the measurement of surface tension. And these problems he did on his own without any guidance from anybody and without any acknowledgement, such as a single paper, name papers. And when after his studying, the formal study, when he started for the job, uh, his elder brother, and all influenced him to go to the civil services. And before the civil appearing for the civil services, there was a compulsory medical checkup for the Indians. So he went for the civil surgeon of Madras for a medical checkup, and he was declared unfit. And probably this was the only examination that he failed, that medical examination. And later on, he said that I shall be ever grateful to the civil surgeon of Madras because he rejected him medically. He found him unfit for the civil services examination. But since, like all of us, there was a pressure from for on Raman for earning his livelihood. So he appeared in a financial services examination and topped the examination. And as soon as he joined the services, he was married in 1907, and he was posted in Calcutta as an assistant accountant general. So while he, he used to go to his office, he used to notice a board called ICS. ICS was the Indian Association for Cultivation of Science, which was founded in 1876 by Mahendra Lal Sirkar. And he was a great patriot and a nationalist. And he founded the society and created basic experimental facilities so that young students can learn science and do some small experiments at that place. But there was nobody responded it in a proper manner. So this building was having a very uh, dirty look, and nobody was visiting it. So when Raman observed this for some time, one day he went there, and there was a caretaker, Ashutosh De, who later on became a co-worker of Raman. And when the caretaker opened the door and he went inside, there were dust all around. Later on, he contacted Amrit Lal Sirkar, who was a descendant of the Mahendra Lal Sirkar. He was a nephew of him. So when he contacted Amrit Lal and said that he wanted to do some science in the lab, so initially he thought that Amrit Lal thought that he is not a very sincere, but after discussing on several rounds and all, he got convinced that Raman will do something sincerely here. And so Raman decided, he handed over the keys to Raman, and it was a basic contract that whatever Raman will do, he will not get any salary from it. And that's how Raman started science. And from 1907 to 1917, for the 10 years, he did both the things. Like in morning, right early in the morning at 5:30 a.m., he used to go to the IECS, do some work there, come back, get ready for the office, and when to go to office. After the office, he again used to go to the association and do work there. And in the night at about 10 o'clock, he used to come back to the home. And on Sundays and holidays, the whole day he used to spend in IACS. So during this process, did some work and is published in reading journals like Physical Review and Nature. So the work which he did in ISCS was in connection to the musical instruments. So the musical instruments that he studies was ektara that we play quite often, violin, and mridangam. So in ektara, Raman observed the tension of the wire, and he said that the tension varies at twice the frequency. In violin, he did some research on the physics of violin and the quality of sound. And in Mridangam also, he did analyze the node lines. Apart from this, he studied on Veena and Sitar. He developed the physics. This is the paper that he published. And in 1917, Sir Ashutosh Mukherjee, who was the Vice Chancellor of the University of Calcutta, offered him a position of professor in the Calcutta University. And at that time, The salary of the professor was nearly half what he was getting as the assistant accountant general. But he left the job of the assistant accountant general and joined the Calcutta University as a professor in physics, and that was Palit chair, named after Tarak Nath Palit, who has donated about 1.5 million rupees to the university for this chair. And there was a condition while joining that whoever will work in on that chair will carry out the research, and that should be in collaboration with the other countries. But Raman refused for the collaboration. But Ashutosh convinced him to go to Europe for a tour, and he went to attend a conference there where he met Rutherford Bragg and J.J. Thomson, who were quite leading physicists of those times. And while returning in the Mediterranean in the ship in the Mediterranean Sea, he got fascinated by the scattering process taking place, and he decided to work on scattering. So after his return, he started work on scattering, and to his research scholars, he distributed the work to study the scattering of various liquids, solids, and gases, and tried to work on the molecular basis of the these effects. So in 1922, he worked on the molecular diffraction of light, and after that, in 1923, he worked on the theory of viscosity. And the basic setup that he used in his experiments was a light source. He used a filter, get a violet light. Here is a transducer with a liquid in it. And after this is scattering, he observed this scattered light. So while using glycerin as a liquid in the transducer, Venkatesh observed that light is scattered in the green range from the glycerin. So, in the month of January 1928, Raman asked his student K.S. Krishnan to take up the experiment work and follow the observation which were made by Venkateswar. So, on 7th February, K.S. Krishnan observed that the liquid exhibit famous weak fluorescence and that the polarization of the fluorescent light is greater the smaller the anisotropy of the molecule. This was the arrangement used by Raman and Krishna. There is a filter, the sample in the transducer, and here is the observer. So on 16th February 1928, he posted a note to the Nature magazine about the fluorescence, and the modified radiation could arise from the fluctuations of the molecules from the normal state. On 27th February, Raman decided to view the fluorescence direct through a direct vision spectroscope. But as they were to perform the experiments, it became dark, so they decided to perform the experiment on the 28th. And when on 28th of February, when they performed the experiment, the spectroscope showed that the track contains not only the incident color, but at least another line separated by a dark space. So Raman communicated this on 29th February, and basically the what was the theory? Let's discuss on it. And the liquid that he used in the transducer was carbon tetrachloride. So what were the features of the observations were that the scattered light from the sample has dominantly the same frequency as the incident one, and a small fraction scatters at different wavelengths. And this difference in wavelength is called Raman shift. This difference can both be on the higher side as well as on the lower side. The higher side lines are called the Stokes lines, and the lower sides are called the anti-Stokes. And this effect is a universal phenomena observed in all the three states, solid, liquid, and gases. This the Raman shift is observed on both sides of the Rayleigh line, on the greater and well on the smaller at the same distance. The Rayleigh line is the center line. It is the same frequency as the incident light. There is a Raman shift on the lower side. This is the incident light. This is the scattered, and this is having a smaller frequency. The shift is delta mu. So as the frequency is shifted, so the energy is also shifted, as the quantum energy is h nu. Here we can see this is the incident photon. This is Stokes line, which is coming to a level slightly above the initial level, while the anti-Stokes line comes from the excited directly to the below the initial level. Here the lines have stopped at a level higher than the initial one. These are called Stokes lines. And here the lines are fallen to a level below the initial one, and the lines are called the anti-Stokes. His research career involved his first research paper, as we discussed, was in the Philosophical Magazine in 1926. And he had a total of 102 publications. These are the breakups from 1912 to 19. At ICS, he published 5 papers. And when he got a professorship in Calcutta University, before the Nobel Prize, he produced 78 papers. And after the revolutionary discovery, he produced 12 papers in the decade, and thereafter 7 papers. The areas were optics, acoustics and optoacoustics, X-ray crystallography, and quantum theory. He worked in these areas only, and he wrote 2 books during this: The Molecular Scattering of Light, The Acoustical Knowledge of the Ancient Hindus. So, while summarizing the works done by him, so the notable works that he did for the country that we are proud of was the discovery of the Raman effect, for which he got the Nobel Prize in 1930. He established institutes like the Indian Academy of Sciences and the Raman Research Institute in Bangalore. He founded the journal, the Indian Journal of Physics, which is published these days also. And his notable students were Vikram Sarabhai, K.S. Krishnan, G.N. Ramachandran, Ramanathan, and Pancharatnam. And these Vikram Sarabhai, K.S. Krishnan are the well-known students that every Indian knows. And he was associated with ICS, where he did the initial work, the Indian Institute of Science in Bangalore, and the Calcutta University. And I end this lecture with a mark that about 90 years have passed to the discovery, and we are still proud of the discovery. And after that, no Indian have been able to go for the Nobel Prize or working in India. Although Indian scientists have got Nobel Prize, but they were working outside India. Raman was the only Indian scientist who got Nobel Prize for his work which was done in India itself. and that too with the limited resources. And nowadays, when we are having better resources, let's strive for getting a Nobel Prize and produce a research that is worth it. So I end my talk here and again wish you all a very happy National Science Day. Thank you.